I am going to explain the term vapor pressure of liquid in this video. Suppose you take a liquid in the container as shown in the diagram. You will observe that some of the more energetic particles on the surface of the liquid will break from the surface of the liquid and move into vapor state. This kind of phenomena is called evaporation. Please note that there is a difference between the term evaporation and boiling. Evaporation only takes place on the surface, whereas boiling happens throughout the liquid. So when you see this kind of a liquid which is evaporating, you will not see bubbles formed throughout the liquid, but when you boil a liquid, you will see that the bubbles are formed throughout the liquid. So this is the difference between evaporation and boiling. Now consider the second case in which we take this same liquid but in a closed container. Now in this case what happens is some of the gas molecule or some of the liquid molecules, they break from the liquid surface and go into vapor state, but some of these molecules again will come back to the liquid state. The process is known as condensation. Now after a point of time, there will be an equilibrium set up between this liquid and gas. Now at equilibrium, the rate of evaporation becomes equal to rate of condensation. In this equilibrium, the pressure exerted by this gas molecules is known as vapor pressure of a particular liquid. I am going to talk about properties of vapor pressure in this video. In the last video, I had described the vapor pressure as pressure exerted by the vapors of a particular liquid over the surface of this liquid. Now, as you observe in this diagram, a equilibrium is established between liquid and its vapor after some time. So pressure exerted by this vapor is nothing but your vapor pressure. Now, let's take an example of water. So there will be an equilibrium established between H2O liquid and H2O gas. So if you find the equilibrium constant of this particular reaction, it is nothing but partial pressure of this H2O vapors. So in short, vapor pressure is nothing but equilibrium constant for this particular reaction. So the equilibrium constant only depends on temperature. So basically I am saying that vapor pressure is just the function of temperature and the liquid that you are taking. So it depends on only two factors, nature of liquid and temperature. So when I say nature of liquid, what we mean by that is it depends on the intermolecular forces. So weaker the intermolecular forces are, easier it will be for the liquid molecules to go into vapor state and more will be the vapor pressure. At the same time, if the intermolecular forces are stronger, it will be difficult for the molecules to go into vapor state and less will be the vapor pressure. Now if you talk about temperature, the equilibrium that is established between liquid and vapor state is an endothermic reaction. So enthalpy will be greater than 0. So as the temperature increases, vapor pressure will also increase. The exact mathematical relationship between the vapor pressure and temperature is given by Clausius-Capron equation. So we say that ln P2 by P1 is equal to minus of delta HV by R 1 upon T2 minus 1 upon T1. Here P2 and P1 are vapor pressure of a particular liquid at temperature T2 and T1 respectively. Delta HV is enthalpy of vaporization and R is universal gas constant. Now whenever you are using this particular formula, always remember that the unit of enthalpy and R should be the same. So if delta H is in joules per mole per Kelvin, R should be 8.314, and if this is in calorie, then R also should be in calorie. So vapor pressure will be basically independent of the amount of liquid taken or the surface area of the liquid or the volume and shape of the container. I am going to explain relative humidity in this video. Relative humidity is the amount of water vapor present in air expressed as a percentage of amount needed for saturation at the same temperature. So mathematically, relative humidity is nothing but partial pressure of water vapors at a particular temperature upon vapor pressure of water at the same temperature multiplied by 100. Let me explain you this with an example. Suppose vapor pressure of H2O at 25 degrees centigrade is 23.8 mmHg. Vapor pressure is also known as aqueous tension, vapor pressure of water, that is. Now suppose you take two cases, one of Mumbai and another of a dry place like Bhopal. So in case of Mumbai, let's say the pressure of water vapors currently is 16.66 mmHg. So relative humidity becomes 16.66 upon 23.8 into 100, that is 70%. And in case of Bhopal, let's say pressure of water vapor is 4.76 mmHg at this point. So relative humidity will become 4.76 upon 23.8 into 100, which is 20%. So in simple terms, you can say that Mumbai's air is more humid as compared to Bhopal. Let us try to understand the relationship between vapor pressure and boiling point of a liquid. So as we mentioned earlier, that vapor pressure of the liquid increases with increase in temperature. So if we make a graph of vapor pressure of a liquid versus temperature, so as you can see in the diagram, the vapor pressure of a particular liquid increases as we increase the temperature. Now the temperature at which the vapor pressure of the liquid becomes equal to external pressure is called boiling point of the liquid, and specifically when the external pressure is 1 atmosphere, we call it as normal boiling point. So if you just look at this graph, I have drawn vapor pressure of two liquids, liquid A and liquid B. Vapor pressure of liquid B increases with increase in temperature and it becomes equal to 1 atmosphere when the temperature is 100 degrees centigrade. So this is your boiling point of B. Similarly, liquid A, if you observe, its vapor pressure increases and it becomes equal to 1 atmosphere when the temperature is 70 degrees centigrade. So I'll say that the boiling point of liquid A is 70 degrees centigrade. One more thing you can notice is at a particular temperature, the liquid with higher vapor pressure has a lower boiling point. Now let us examine what happens if the external pressure is changed from 1 atmosphere to, let's say, 2 atmosphere. So now the boiling point of the liquid will increase from 100 degrees to, let's say, 120 degrees centigrade. This is just an example. So the vapor pressure keeps on increasing with increasing temperature. Now as we mentioned earlier that the boiling point of the liquid is the temperature at which the vapor pressure of the liquid becomes equal to atmospheric pressure, or basically external pressure. So in this case, if the external pressure is 2 atmosphere, so my vapor pressure has to be equal to 2 atmosphere, and that happens at a higher temperature than the normal boiling point of 100 degrees centigrade.